This week we cover PLD Space offering free access on their first two launches. Rocket Factory Augsburg gives us a sneak peek at their launch pad. Sidereus Space, an Italian launch company, conducts a hot fire test. And finally, Orbit Fab conduct an orbital refueling test. Let's get started. PLD Space offers free access to space on its first two Miura 5 missions. PLD Space announces its Spark program, offering educational centres, universities and companies worldwide access to the first two Miura 5 launches completely free of charge. The company will cover mission costs to promote scientific and technological innovation aimed at improving life on Earth from space. This is a great opportunity for organisations, universities or companies that want access to space but can't afford the launch costs. This opportunity would be perfect for a space startup that has a great product or service but doesn't have the funding for a launch yet. Why not contact PLD Space and make a pitch to them? This initiative is supported by the Spanish Space Agency. Here's a quick list of the requirements. The combined mass of all satellites cannot exceed 450 kilos. Payloads will be launched into a sun-synchronous orbit at an altitude of 500 kilometers. Priority is given in the following order: Spanish, EU, NATO and major non-NATO allies. And finally, payloads with contributions from students also have a priority. The first application period ends on the 30th of July 2024. Shortlisted applicants will be notified by the end of August, and final selection of candidates will be on the 30th of November 2024. The flights are scheduled for 2025 and 2026. Okay, let's move on to Rocket Factory Augsburg to see how they're progressing on their first orbital launch attempt. RFA finishes building its Stage 0 launch pad. Launch pads are essential for launch providers, but they usually don't get much attention, at least from space enthusiasts. Rocket Factory Augsburg, in a recent blog post, took us behind the scenes and showed us what they've been up to for Stage 0. If you're not familiar with that term, it means all the ground support equipment such as fuel tanks, pipes, flame trench, and all other support equipment necessary for launching a rocket. RFA needs 40,000 litres of fuel and 125,000 litres of liquid oxygen to fuel the rocket. In addition to that, 125,000 litres of nitrogen and 5,000 litres of helium are used. Putting all these liquids into the rocket stage at precisely the right temperature and time is not easy. You might be wondering why they chose Saxford Spaceport to launch from. It's a remote island right up at the tip of Scotland. Well, RFA carefully considered a number of different spaceports before deciding on Saxford. The Saxford area has a rich oil and fishing industry with existing infrastructure such as industrial harbours, tool stores and suppliers. The spaceport operator also has the same can-do spirit as RFA, which helps getting things done quickly without all the bureaucracy of large operators. And finally, it has the perfect location for polar orbits. It's one of the most northerly inhabited islands in the UK. Launching from the equator is important when you need that extra fling from the planet spinning. It benefits further or higher missions such as GEO, lunar or interplanetary missions. For RFA, it's not a big factor though. The more interesting commercial missions are Earth observation and constellation missions that end up in sun-synchronous and low Earth orbits, so the extra fling isn't needed. Here's a render of how the RFA launch pad will look. The stand is made of steel with 4 legs and built to withstand the strong winds and salty seawater. Integrated into the system is a water deluge system. This douses the flames from the engine and, very importantly, dampens the enormous roar of the 9 helix engines. The fuel farm is situated away from the tower structure. It contains all the fuel, oxidizer and inert gases necessary to fuel the vehicle. The liquid oxygen that is used to react with the fuel needs to be kept at -183 degrees Celsius. Stage 0 has over 1,000 sensors and 1,400 valves and regulators. The launch pad has 8 massive hold-down clamps to stop the rocket leaving the pad during static fires. In classic startup style, RFA repurposed a commercial site crane for its hold-down clamps. Cheap, pragmatic solutions to get things done quickly and for low cost. Okay, let's move on to an Italian launch provider. I bet you didn't even know there were Italian commercial launch providers. I didn't until I saw this story. Sidereus Space Dynamics completes a static fire test. Italian rocket builder Sidereus Space Dynamics has completed the first integrated system test of its EOS rocket. Sidereus was founded in 2019 and is developing a single-stage rocket called EOS. Yes, You heard me right, I said a single stage to orbit vehicle. Rockets require 2 stages to get to orbit, a booster stage that takes the vehicle through most of the atmosphere, and then a second stage to get the payload into orbit. Single stage rockets, however, get the payload directly to orbit. How is that possible? Well, Sidereus will have a very small payload capacity, only 13 kilos, that's 28 pounds. The vehicle is tiny, only 4.2 meters tall, that's about 13.8 feet, and the vehicle is reusable and will be recovered by deploying a parafoil. On the 30th of June, the company performed its first fully integrated system test of the EOS rocket. During the test, the rocket's MR5 main engine was successfully fired for approximately 11 seconds. The company is beginning to prepare for the first low-altitude EOS test flights. This marks an important step in the development process of EOS, paving the way for optimization ahead of our upcoming milestones, Sidereus COO Luca Principi told European Spaceflight. We're now preparing for a 500-meter flight test to validate subsystems in flight and further optimize EOS in a controlled environment, advancing towards experimental orbital flights. To date, the company has raised a total of 6.6 million euros. That's about 7.1 million US dollars. This is pocket change compared to some other European rocket companies, such as ISA Aerospace or RFA. The company's CEO, Mattia Barbarossa, has previously stated that the company intends to reshape spaceflight in a fraction of the time and with limited resources. This is a fascinating company, and rest assured, we will be covering Sidereus now that we know it exists. And for our final news story this week, Orbit Fab successfully demonstrates refueling tech test. Orbit Fab is an orbital refueling company. Think of them as a gas station in space, with over 10,000 active satellites in space at the moment, and with that number sure to increase, refueling satellites in space seems like a good business opportunity. Orbit Fab has just wrapped up testing on its automated grip refueling system, the company announced on Tuesday. At a test facility in New Mexico, they successfully tested their Rapidly Attachable Fluid Transfer Interface System, or RAFTI for short. After the test, their CEO Daniel Faber said, "Our main technology risk is now behind us." Orbit Fab has already shipped its system to customers in the US and Europe, so they can test the refueling system against their hardware. They intend to launch a demonstration system into orbit in late 2025. They have signed a number of contracts with Space Force, a US government agency already. Orbit Fab thinks the future of space is where orbital refueling is common, and they think the future will come soon. Orbit Fab wants to concentrate on fuel cells in space and license its RAFTI technology to partners, allowing for integration of this technology across many different satellite platforms. Thanks for watching this latest Space Startup News update. Be sure to subscribe to get the latest news on commercial space startups around the globe. From Earth to orbit, the moon or further, we've got you covered. See you soon.